The graphs of three normal distributions are displayed below. The distributions have been labelled A, B, and C. First thing we're asked is for the mean of distribution A. Well, the mean always corresponds to the peak. So the answer there is 2. Which of the distributions has the largest standard deviation? Well, what we're looking for there is for the most spread out one. So that's going to be C. It does say justify your answer. So I would say something like it's more spread out or more dispersed. A random variable x is normally distributed. The distribution of x is graphed below. It's asking us to shade the region with area corresponding to x being between 6 and 9. So in other words, 6 and 9. And we're going to shade that region. And then we're asked, is that probability greater than or equal to 0.5? And we need to justify your answer. Well, the first thing I would say here is that the total area enclosed by the graph is 1. So we need to look at the area outside compared to the area inside. And we can literally do this by counting squares. So if we look inside, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. This one we'd count as it's more than half. And I think we'd probably count this one as being more than a half. So what did we say? We had 17, 18. So I'd say that's approximately 19 squares there. What about outside? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and there's definitely more area there. So we could use some sort of indication like that there is more area outside. So more area outside implies that the probability of the outside is more than 0.5, and that means that this probability here must be actually less than 0.5. Now, the last part of this question says a random variable y has probability such that the probability of y is greater than or equal to 2 is more than the probability of y is greater than 2. Explain whether it's possible for the distribution to be normal or binomial. Let's look at normal first. So we know that normal, that's continuous. Therefore, the probability of y being actually equal to 2 is 0. So this situation cannot be true. But for a binomial, the probability of y being equal to 2 is definitely finite. And therefore, the probability of y being greater than or equal to 2 is more than the probability of y being greater than 2, which remember is the same as the probability of y being greater than or equal to 3, since the binomial is a discrete distribution.